Another concept that we worked on towards the end of this chapter is squares, cubes, and then order of operations and how all of those pieces kind of fit together. And so when we're talking about squares, it's best to use a visual on this. And so if we're thinking of like the square of 4, if you were to represent this with a visual model or like a picture, you could draw a square. Let's see if Notability will help me. Come on, Notability, wake up. There we go. So if we have a square and it has side lengths of 4, you can know that to find the area, or the amount of space on the inside here, that's our area, you would need to do length times width. So in this case, that would mean that the area equals 4 times 4, or we could write that using an exponent. So area equals 4 squared. And so we would read this as 4 squared. And in this 4 squared, I'm going to draw it a little bit bigger so we can see. This number down here is called the base. And this little number up here is the exponent. And so the base is the number that you are multiplying repeatedly by itself. And then the exponent tells you, the number you are multiplying by itself. And then the exponent tells you how many times you are doing that. So because this is 4 squared, that means the exponent is a 2. So when you see this, what you really could think of is 4 squared is the same as 4 times 4, and that equals 16. So this is kind of a nice way to connect a lot of the work that we've done with geometry, multiplication, looking at exponents, and then trying to find a more efficient way to write out what we're doing. So the next layer after this, considering this is a 2-dimensional shape, meaning it has 2 dimensions, length and width, is if we transitioned into a 3-dimensional shape, where our shape is going to have 3 dimensions, our length, our width, and our height. And so taking this idea of a square with side lengths of 4, we're now going to be looking at cubes. And so this cube that has a length and a width, we're now going to add this next dimension, and it's going to also have some depth there. So instead of finding area now, we are going to be finding the volume, which is the length times the width times the height. And as you can see from this problem, that is going to be 4 times 4 times 4. And 4 times 4 is 16. 16 times 4, 10 times 4 is 40, plus 6 times 4, that's 24. So 40 plus 24 is 64. So we would say that the volume of this cube is 64 cubic units, or units cubed. So building on what we set up here about this base and the exponents, if you look here at this, I'll rewrite 4 times 4 times 4, the number that we're multiplying repeatedly is 4, so that makes it our base. And the number of times that we are doing that is 3 times. So that means our exponent, or our power, is going to be 3. So we would read this as 4 cubed. Now, squares and cubes are really the only ones that have their own special terms. If we were to branch this down even further and say we were doing like 4 times 4 times 4 times 4, your base would be 4, and then the number of times that we are doing this is 4 times. So we would read this as 4 to the power of 4. So that's kind of how we would connect squares and cubes and this repeated multiplication and exponents all into one thing. And so there is one more term that I forgot to throw out there, and that is this idea of a perfect square and a perfect cube. And so you could think of these definitions as like the result of squaring a number, or a perfect cube is similar, but it's the result of cubing a number. So in this here, the example could be that 64 is the perfect cube. I'm just going to write PC, perfect cube of 4. Because if we took 4 cubed, we got 64. Same thing here. The perfect square, 16, is the perfect, I'm going to put S for square, perfect square of 4, because 4 squared equals 16. Now, this is, you might be wondering, like, why are we looking at this in this chapter right here, squares and cubes? Well, if you notice, 4 times 4, or 4 times 4 times 4, we're starting to see that repeated addition that might look similar to when we were doing prime factorization. So when we did prime factorization, let's say the number was 8, we would first pull out a 2 because that's our smallest prime factor. That leaves us with a 4. We can repeat that, and so we know 8 equals 2 times 2 times 2. So as your numbers get bigger, obviously this stretch of prime factors is going to get longer and longer, and so we need to find a more efficient way to record that. And so that's where we would use this idea of like the exponents or the powers. So our base is going to be a 2 because we multiplied 2, 2, and 2. And the number of times we did that is 3 times. So you could say that using the prime factorization of 8 equals 2 cubed. Now this also does work with numbers like 20, where if we prime factorize this, we know that 20 equals 2 times 2 times 5. Now if you notice, we have 2 different factors. We have some 2's and we have a 5. And so when we're using exponents, we're going to group like factors. So 20 here equals, let's see, turn this into our exponents. Our base is a 2, and there's 2 of them. So our exponent is a 2. And we still need to multiply that by 5. Because if we look at this and we left off that 5, we would only have 20 equals 2 squared. And 20 is not actually equal to 4. We do still need that times 5 on the end there. Now, I did say that this video is also about order of operations. And so when we are doing order of operations, you might think of PEMDAS. And I would encourage you to think of PEMDAS like a pyramid, where yes, we will do the parentheses first, then we will do the exponents. But when we get to multiplication and division and addition and subtraction, those two operations are grouped together. And so we need to do these from left to right. And I'll show you an example of what that means. So last year when we looked at order of operations, it did not involve exponents. And so now it is going to involve exponents. So if we have 9 squared plus, let's see, in parentheses, 2 cubed minus 3 squared here, we know that starting at the top of our pyramid, we need to do what is in the parentheses. And when we zoom in to inside of these parentheses, you notice that we have 2 different types of math we have to do. We have our exponents and we have some subtraction. So it's almost like inside of our order of operations pyramid for this whole thing, we're going to be doing a smaller pyramid inside the parentheses. So in that smaller pyramid, we need to do those exponents first. So 2 cubed is 2 times 2 times 2. And 3 squared is 3 times 3. So 2 times 2, ooh, this may have been a bad example because that's going to get us a negative number. Whoops, I'm going to quick flip-flop those around. I was trying to come up with this on the fly. So we'll keep those same numbers, but we'll do 3 squared minus 2 cubed. How about that? So this is going to be 3 times 3. This is 2 times 2 times 2. So 3 squared is 9. 2 cubed, 2 times 2 is 4, times 2 is 8. And so we do want to keep those parentheses and bring it all down. So when doing order of operations, I strongly encourage / require that you write down every single step and that you do bring, so if you notice, we only solved these 2 parts to get this here, but then transferred all the rest of the work that we have to do down with us. And it's really important that you do that because otherwise you might miss a piece or leave a step behind and then you'd get the wrong answer. So we have all of that Transfer down. We still need to finish out the parentheses. 9 minus 8 is 1. So now we have 9 squared plus 1. So we've gotten rid of those parentheses. Let's move on to the exponents. 9 squared. In my head, I'm thinking this is 9 times 9. That's 81. And now I'm just left with addition. So 82 is going to be our answer. And you can check to see, did I record enough work? Because it will be shaped like a pizza. So I'll do one more example because I know that one. I did a lot of explaining of other steps in there, and I just want to make sure that we have this all set to go. So if we do, let's say, actually I'm going to pause there. It sounds like people are outside. So hopefully this makes sense. If not, you can just Google it and check in your math book.